everybody. We are starting chapter 5, which has to do with graphs and derivatives. And today is our day 1. We're going to be looking at something called the first derivative test. And what that is going to allow us to do is to create a sketch of a function by looking at increasing and decreasing intervals. So if we take a look here, and just like I said, it's going to allow us to draw or sketch the function. And we're going to be looking for areas that it would be increasing and decreasing to give us an idea of the shape. So if you would look here, increase to decrease would be something like that, where there would be a maximum. And decreasing to increasing would be something like that, to where there would be a minimum. So how do we do this? There are 4 different steps. So the very first one we want to do is to find the first derivative, which is what we've been working on. And we're going to do something called identifying critical values. Now that is going to be where the derivative is 0, which would be a horizontal tangent, or where the function is undefined, which would be an asymptote. After we identify those, we're going to use something called the number line test to try to identify the increasing or decreasing based on either side of those critical values. Because it's at the critical values is where you're going to find the max or the min or the change in the asymptote. So we will draw the number line, test values on both sides, and if the derivative is positive, then we know it's an increasing interval. If the derivative is negative, then we know it's a decreasing interval. And then the next thing we would do is sketch the graph. And we'd be using max and mins and that information to turn around and graph a sketch of the function. So again, we're using the derivative information to turn around and graph the initial function. All right, on to the next page, we're going to do all right, so to use this example to sketch a graph of that function. So here we go. The first thing we want to do is the first derivative. And if you take a look at this function right here, we are using the power rule. So what would that give us? Negative 3x squared minus 4x plus 15. So I just did the power rule of the original function. So the next thing to do is to identify the critical values. So for number 2, now that is where you're going to see change in the functions. So we have our derivative, and in order to find those, we need to set it equal to 0 and solve. So if you notice, this is a quadratic, which we would turn around and factor. So we're going to go ahead and get rid of that negative by changing all the signs. And this would factor to 3x minus 5 and x plus 3. Set them to 0, we would get 5/3 and negative 3. So then we are going to do our number line test. And what does that look like? So what we do is we draw a number line with those critical values on it. So there's going to be negative 3 and 5/3. So what you want to do, let's put our infinities there as well. So what you want to do is you want to test on either side of those critical values. So we're going to pick a number to the left, and we could do negative 4. In between here, a good number to do would be 0. And on the far right, a good number to do would be 2. So you're just looking at numbers in between those critical values. So we are going to plug these values into our derivative to get an idea of whether it is increasing or decreasing. So now we are going to take that negative 4, 0, and 2 and put those into the derivative and see what value we end up with, whether it's positive or negative. We're not really concerned with the number, we're just concerned with the sign. So we're going to put in negative 4 squared minus 4 times negative 4 plus 15. And if we actually work that out, we would end up getting a negative value. So let's just go ahead and put that symbol right there, or that, yeah, here we go. So that is negative on the left of that negative 3. So right above that negative 4 and that negative 3, that portion is going to be negative. So it's decreasing. And then for the next one, we are going to put in that 0. So negative 3, 0 squared minus 4 times 0 plus 15. That just leaves us with 15, which is positive. So our testing of 0 in between the negative 3 and the 5/3, that is going to be positive, which means it's increasing. The next one we are going to do is the 2. Negative 3, 2 squared minus 4 times 2 plus 15. And if we did that on that one, we would have what? Negative 12, negative 8, negative 20. So this is going to turn around and be negative. So we would have negative on the right side of the 5/3. Because again, what you are looking at is you're going to have your critical values and you want to decide whether it's increasing or decreasing on either of those sides. So what we're going to do is identify in a little bit more math notation where we have increasing and where we have decreasing. So we're going to just look at those intervals. So it is increasing between negative 3 and 5/3. It is decreasing negative infinity to negative 3 and 5/3 to infinity. Now we can use this information to turn around and sketch the graph. So this is where we're going to sketch the function. It would look something like this. So let's just do our coordinate. And then we're going to have a value of negative 3 as that critical value and the other value of 5/3. And what is it telling us? Between negative infinity and negative 3, it's going down. And that 3, this is where we said it was equal to 0. So that was our horizontal tangent line. And we figured that out. And now it's going positive between negative 3 and 5/3. And then it's headed back down negative. So at those critical values, again, that's where your tangent line is horizontal and has a value of 0. So we are looking to see what happens on either side of the critical values to give us a sketch of the function. See you next time.